Okay, so today we will be looking at classes. So, like I mentioned in one of the earlier classes, um, a class basically consists of data and functions. This data is also called attributes or fields, and functions inside a class are called methods. Okay, so let's look at an example, say that of a person class. So let's say we have a class person, and let's assume say some attributes of this person like name, age. These attributes are present in this class, and also there is a function, say introduce. That is, the person introduces himself or herself saying my name is so and so and I am so many years old. Okay, so this is the basic class of a person. Now for this person, this is a template class. Like I said, is like a template. You need to instantiate this template with specific people, right? So we can have objects or instances of this class. So objects means specific people, right? Like this particular person or that particular person. So we can say some people like maybe some Ravi or Anil or Mohan, whatever it is. Some names, these are three people. Each of them will have all these fields and methods. Okay, so class is like a template, whereas specific people are instances of that class. So we need to instantiate specific people, right? So let me show a demo. So let's create a new class. So command palette. So new project, let's create a new project. Console app, and let's call it classes. Okay, so now first let's fill all these things. Within namespace we have classes. So within this we have the main function, right? Static void main. Okay, so this is one class. So whatever we want to write inside this, whatever we want to do in the code, we'll write inside the main function. But before that, let us define a class called person, right? Class person. And what are the fields? One is name and age. Okay. Now, so before that, so how do you declare a class? Basically, a class has three things. One is the access modifier. It can be public, private. Right now we will look at only public access modifier, and then the class keyword, and then the class name. Okay. So when you make something public, when you make a class public, it is accessible by other classes as well. Okay. So one instance of that, one use case of that is like, can you guess what is the use of making a class public in Unity? Like we can build games in Unity, right? So, and there are scripts for different objects. If you make an object public, what is the use case? What will be the use? Sorry? No, editing, when you go to the file, you can edit whether it's a public class or private class. But making a class public makes it useful in a different sense. You need not even go to the file again. You see, like I said, everything that you see in the panel on the interface, that has some code behind it. And most of the times we are able to modify some of the regularly used things through the interface itself, like the speed of an object or the position of an object, these kind of things through the interface itself, right? We can go to a text field and change the number. So how is this becoming possible? It is because those specific attributes of the player, say like speed of a player, that attribute or field of that player, that was made public. So whatever you make public in the file, those are visible in the panel. So you can edit those values through the panel. If they are not public, then you can't edit them through the panel. You have to go to the script and change. Because they are made public, they are allowing some external user also to edit them. Okay, so this is a very good example of public class and public attributes. Okay. Right now we will use only public keyword. We will look at private keyword later. Everything will be public. Class and its attributes and functions, everything will be public. Okay. So one is name of the person. So what data type will it be? String. We will make this also public. Okay. What is another field? Age. So what data type should we use? Int we can use, or since age will be very small number, we can use byte. Yeah. Byte range is 0 to 255. Age obviously will never cross even 120 or something like that, or 150 max. So byte is more than enough. We will make this also public. And then introduce. Introduce is a function. Okay. Since it is part of the class itself, basically when we want to introduce, if in C or C++, not C++, in C, if we had to write a function like introduce, and okay, so first let me specify this function. Let me make more space. So suppose in this function, what do I want to do? I want to say sorry, I am so and so name, and I am so many years old. Okay, so here we are assuming name and age are available to us. Normally in C program, what do you need to do? You need to pass them to the function, right, as attributes. But here you don't need to pass them to the method as attributes, because these methods are part of a class and the other fields in that class are public, so they can be accessible by this method. Okay, so you don't need to pass them. All right, and does this function return anything? No, you're just printing, you're not returning anything. So the return type is void, and let's make this function also public. Okay, simple. Now let's code this. So let's make this class public. Name is a string, public string name, and then public byte age, and public void introduce console.write I am whatever the name is. Okay, and I am whatever the age is, years old. Okay, simple. All right, now this is the definition of class. Okay, we need to now instantiate this class. Different people will be there, their names are different, their ages are different, so we need to create different objects and instantiate them, give values to those objects. Okay, so now let us instantiate class, objects of this class. So how do we instantiate a class? So normally how do we declare a variable? Like we say like int x, right? Similarly, if you want to declare a class object also, it's quite similar. Whatever is the class name, that will be your data type. In our case, this class name is person, so we can say person p1, person p2, and so on. All right, but a class is slightly different. You need to allocate space for that explicitly. Computer does not decide the space, so you need to write a command saying that new, and again class name with brackets. Okay, so this will create a new object of type person and allocate space for that. In C++ and Objective-C and even in C, when you allocate memory, you also have to take care of deallocating that memory. Like, I don't know if you remember this command like malloc, calloc, those commands, you allocate memory. And then you also need to free that memory. You need to write the command free. Okay, but in C#, you need not worry about deallocation. That will be taken care of CLR, common language runtime, because it has some method called garbage collection. It will take care of deallocating the unused memory, free memory. So you only need to worry about allocating memory, not deallocating it. Okay, and now once you have say person p1, now you can populate the values for each field and function. So you can say p1 dot name equal to say whatever Ravi, p1 dot age equal to 20, and then you can call the function p1 dot introduce. Similarly, p2, p3, any number of objects you can create. Okay, So let us see. So you see, objects will not be created in the class. Objects will be created in the main function. That class, you create objects of that class in the main function. Class is outside main function, but the code related to creating objects and all that will be written inside the main function. Okay. So person p1 equal to new person. And by now you would have noticed that each statement should end with a semicolon, like C. Code blocks need not end with a semicolon. Those which are brackets, they don't need to end with a semicolon. Okay. Those which don't have brackets, they need to end with a semicolon. P1 dot name is, say, Ravi. P1 dot age is 20, and then P1 dot introduce. Okay. Now let us run this, but before that I need to change the folder. Yeah. So let me run it. Yeah. This is just a warning. You ignore this for now, non-nullable field and all that. It's not an error, but the code is working fine. You see, it printed, I am Ravi and I am 20 years old. Alright, so let me quickly create two more. Person P2, P2 dot name, P2 dot age, and P2 dot introduce. Say this name is Anil and age is 30, and similarly P3 Mohan 40, whatever. Okay, so let us print. Yeah, it's doing the job. Okay, so yeah, now the way we were able to replace any data type name with var, even for classes we can do that. Okay, instead of person we can say var. This will also work. So let us try it. See, that is also working. Okay, so var is not only for primitive data types but also non-primitive data types. Actually, now we are discussing non-primitive data types, classes, and later we will discuss arrays, lists, and enums. Okay, so these are all non-primitive data types. Yeah, so this is fine. Clear so far? Any doubts? So yeah, now let us create. So you see, the more and more classes we create, the more clumsy our code gets. So usually a good habit is to separate each class into a different file. All right, so even this person class we will separate into a different file called person.cs. So what I will do, I will make a copy and paste it, and I will change this to person.cs, but I want only person class in person.cs and program class in program.cs. Okay, so in person.cs I will remove this program part, and in program.cs I will remove the person part. Okay, Now also the code will run because both of them are in the same project, same namespace, right? This is in namespace classes and person.cs is also in namespace classes. Okay, so now also we can run the code. It's working. All right, so keep your main program in one file and all the classes in different files. Now I will create another file. Okay, before I create, let me explain. So let us create another class called, say, calculator. So and in this class called calculator, let us have attributes like color and price and functions like add two numbers and subtract two numbers, right? Now we can create objects like C1, C2, and say C1's color is black, C2's color is white, C1's price is whatever, and so on, and add and subtract in each object. Okay, so first let's create that and then I'll explain. So let me take this person.cs, let me copy and paste and change this to calculator, and let's remove this, let's make this calculator. Okay, there is an additional yeah. So each calculator will have, say, color. What will be color? What data type? String, public string color, and price can be integer. Okay, public int price, and methods are two methods, add and subtract. Okay, so before I mention the data types and all that, suppose add oh, this is not letting me do this. Addition, let me this is irritating. Yeah, add, inputs are two integers, right? Int a, int b, and what will it return? Addition of a and b. So you can just write return a plus b, right? Here the syntax is very much similar to C. So what will be the return type? Int, and let's make this function also public. Similarly, subtract, return a minus b. Okay, so now you got a calculator class with fields like color and price and functions like add and subtract. All right, now let us create relevant objects in the main function. Okay, what are the problems? All these are warnings, so nothing to worry, ignore these warnings. So let's come to program and let us create objects of type calculator. So calculator C1 equal to new calculator, Okay, C1 dot color is say black, C1 dot price, let's say 1000, and C1 dot add to numbers whatever, 50 minus 20, C1 dot subtract 30 29. Okay, similarly calculated C2. So for C2, instead of using the name calculator, I will say var C2 equal to new calculated. Since I am saying new calculator, it will understand that this type is of calculated. Okay, C2 dot color say white, C2 dot price say 2000, and C2 dot add 39.9, and C2 dot subtract 84,239. Okay, now in add and subtract functions, we did not give print statements, we just said return. All right, so we need to print them in the main function. So simple way is you put this entire thing in the console.writeLine. Okay, sorry. Okay, all right, now let us run the code. Yeah, initially people we have created objects and then calculated. So first is add 50 and minus 20, you will get 30, then subtract 30 and then 29, you will get 1, and add 39 and 9, you will get 48, subtract 84 minus 239, you will get minus 155. Okay, right? Now if you notice one thing, you see color and price, they vary from object to object or instance of calculated. For each instance, color and price will vary, but the add and subtract functions, do they vary from calculator to calculator or object to object? No, right? So it is useless to create a separate instance of add and subtract functions along with each calculator class, along with each calculator object, right? So right now what is happening? You have C1, you will have its own color, its own price, its own instance of add function, and its own instance of subtract function. Similarly, you have C2. Let me copy this only. How do I paste? Let me just write it. You have C2, you will have its own color, its own price, its own add and subtract functions. So for every object of calculator that you create, so many copies of add and subtract functions are also being created. But that is useless, right? You don't need so many copies of add and subtract. Add and subtract are always same, independent of calculator. Okay? So what we can do, rather than making them part of the object, we can make them part of the class itself so that they appear only once. So they should not appear here. They should not appear here. They should appear directly in the calculator class. Okay? So anyway, we have calculator class. Here only we need to see add and subtract functions. Alright? So a simple way of doing it is to make each of those functions static. So in calculator class, rather than just saying public int add and public int subtract, we will say public static int add and public static int subtract. Okay? So when you make anything static, that is accessible only directly from the class, not its instance. So far, if we have to give values to the color or name or price, what did we do? We did not give values in the class itself. You see, here I did not give any value to color. I didn't say this calculator class is black or white. I did not say. I first created an instance called C1 and then I gave a value to that color. Similarly, I created an instance called C2 and I gave a value to that color. Okay? So usually you give values to fields or anything after creating an instance of that class. Okay? But if you make something static, then you cannot access those objects through the objects of the, then you cannot access those fields or methods through the objects of the class. You can access them directly through the class itself. Okay? So now if I try to run this code, you see it is giving red underline. Why? It is saying member calculator.add cannot be accessed with an instance reference, qualified with a type name instead. So it is saying you have to directly, and you see the next line, int calculator.add. It is not saying c1.add or c2.add. You have to use calculator.add. Alright. So let me copy this code and at the same time comment it. Here I'll make the changes. So instead of saying c1.add, I'll say calculator.add and calculator.subtract. Similarly, here also I should say calculator.add and calculator.subtract. Okay? Now let us run the code. Now also it is working. Okay? It will work now only if you directly access add and subtract through calculator method. Okay? Now, no matter how many instances of these calculators that you create, you can create million such instances. You can say 1000 also. In all of them only you will have color, and price. You won't have add and subtract. So you can create million instances of calculators, but add instance and subtract instance will only be one, and that will be directly with the class, not the individual objects. Okay? So this static is relevant to what I explained in one of the earlier classes. Like I said, static is not same as constant. static in a function, when you declare a variable as static inside a function, even when you come out of that function, that variable will remain in the memory. So that when you come back to that function, you remember one of the earlier functions, count. So where was it? Yeah, this example. So here in the counter function, we made count variable static. So even when you actually, this count variable is local to that function, okay, but still normally local variable will disappear when you leave the function. But here when you call the counter function again and again, it will use the earlier value of count and increment from there. That is because count is stored in static memory of RAM and it will not be erased even when you leave the function. Okay, so that is exactly what is happening with the static variable here, static method and static fields in our code. Sorry. So here add and subtract, now when you make them static, they are stored at class level. They do not they are not created and destroyed with the objects. They remain like that and only one instance of them is created and not multiple instances. Okay, so that is the use of static methods or fields. Okay, and one more thing, since we are on the topic, I just want to mention scope of a variable. You all know global variables and local variables, right? So suppose I have a block of code, I say int a equal to 5 and another block of code I start. So this block I'll close here, this block I'll close here, and here I say int b equal to 6 and another block I'll start here, here I will say int c equal to 7. Now, okay, this is not looking neat. Let me make space. Yeah, now let me put another block and inside I will write int c equal to 7. All right, now so suppose this is block 1, this is block 2 and this entire thing is block 3. Now what is the scope of C? What is the scope of C? Where is C visible? Only in block 1. It is not visible in block 2 or block 3. And scope of B? Which blocks is it visible in? 1 and 2. It is visible in both block 1 and block 2. And scope of A? All the 3 blocks. Okay, as simple as that. So if a variable or a function or a method, whatever it is, if it is declared inside a block, its scope or its lifespan is only within that block and subblocks, not its parent block. That's all. Okay, so if I try to print C here, it will give me an error because C is over here. It will not be visible outside. Whatever I have to do, printing C, whatever, using it in some operations, I have to do it inside block 1 itself. If I try to access it, say print C in block 2, it will not print it. It doesn't even know that variable exists. Okay, so this is the scope of a variable. So whenever we are declaring or using any variables, always keep in mind the scope of those variables. All right. Another example of static method, that is which is directly accessed from the class itself, is this console.writeLine itself. You see, this writeLine is a method, but we are calling this method not from the instance of some class, but from the class itself. Console itself is a class. So this method is directly associated with that class. It is because it is a static method. Otherwise, we need to create an instance of console every time, and we need to call this writeLine method from that instance of console. But printing or writeLine will work in the same way in any instance of console. So we don't really need to create a separate instance of console every time. Okay. Another example of static method is main itself. That is why we have this keyword static before main. So this main is the entry point for our entire project. There will be only one main. So you don't need multiple instances of your class program and multiple instances of main for in each instance of class program. You need only one main function and one instance of it. So you declare it as static. Okay. So that is the difference. All right. So now enough explanation. All of you do some coding now. Whatever I said, you try to implement it. So first, so I will show you, you try to follow that. So I will show it from the beginning. Okay, anyway, so open command palette, or you can say view, command palette, new project, console app, and name it classes. Contains an item named classes. Okay, so let me delete this. No, let's say this is let's see if it will work. Command palette, new project, console app. Okay, it's not working. I will use small letters. Okay, it is not allowing that also. So let me delete this for now, or let me move it to a different folder so that it's not visible here. Cut. Suppose if I move it inside this, what will happen? Let us see. Okay, whichever project, as long as it is in this folder, it is not allowing me to create anything. So okay, I will create a folder called classes1 or classes2. You create classes. Okay, so let us not waste time for that. New project, console app, I will say classes2, but you create name classes. Okay, so come to this folder, open program.cs. all right, remove this line, and type namespace classes. You type classes, I type classes2, doesn't matter, and inside that write class program open a block, then write static void main, open a block and keep it as it is. Okay, and now above this, you're following me, or should I go slow? Yeah, above this write class person, actually public class person, and inside person, name and age all are public, string name, public byte age, right? And then introduce function, public void introduce. Now can we make this introduce function static? No, right? Because each person's introduction will be different. If you make it static, that is like introduction for the entire class, that is of no use. How will you have one introduction for all the people, right? So you cannot make this function static. So depending on the example, you need to decide what to make static and what not to make static. All right. So in introduce, we will say I am your name, again open a string, and I am space age years old. Okay. All right. This much is clear. You both just move around and see if everyone is following. Done? Okay, so we sort of just created the class, defined the class. Now we need to create instances of that class in the main function, right? So how do we create an object of class person? Person, say P1. P1 is an instance of class person, right? Equal to new person, class name, and empty brackets. All right, now you got a new person called P1. Now populate the values of each object. So P1 dot name, whatever name you want, you give. I am giving some random names. P1 dot age, and now P1 dot introduce. Okay, this much is clear. Now let's run it. You need to change the directory. You need to go to your respective folder. Don't follow my this thing. If you check your current folder like pwd, you can come to codes folder. If you are already inside some project, inside the codes folder, you can go to the parent directory by doing cd dot dot. Now I am in codes folder. Okay. Now I can go to any folder I want. Now I can go to classes folder or console app 1 or data types with var, whatever it is. Once I am inside codes folder, I just need to type cd that folder name. Okay. If you are already inside some folder, in a different folder inside codes, then you come back to codes folder by doing cd dot dot, cd space dot dot. You will come to codes folder. Once you come there, now go to the folder you want. Okay. So now I am inside cd classes 2. Now you can run the code using .NET Run. It ran the code. All right. Yeah, you are stuck somewhere. Done. Is anyone stuck somewhere? Let me know. And we can create as many objects as we want. So you can just copy this code, paste it to create 2 more objects, P2. You can change these values and 1 more copy, P3. And change these values. And you can come here and run the code again. It should work. So let's stop here.